Okay, so this is my partner Anne's circuit. It's not on right now, that's why there's none of the LEDs are on. But so her circuit is wired up basically the same as mine, except over here, where in my circuit this was a quad NOR chip, this is instead a quad NAND chip. And this one, instead of being a quad AND, as it was in my circuit, it's a quad OR. So she's demonstrating the NAND OR DeMorgan's theorem. So this LED over here, it's connected to the output of a NAND gate. That is the NAND of the clock and switch 1. So because of the way a NAND gate works, as I demonstrated in my truth tables, it's going to be on all the time except when the clock and the switch are both giving outputs of 1. So when the switch 1 is pressed, this LED should flash opposite the clock because it's going to be off when the clock is on and on when the clock is off. This is when switch 1 is being pressed, but not when it's not being pressed. This one over here is connected to the OR of 2 NAND gates. So that's the NAND of the clock and itself, and then the NAND of the switch 1 and itself. And the result, as I show in my truth tables, is that this LED will flash on and off when switch 1 is on, and it's going to do the same thing this one is doing, where it's on when the clock is off and off when the clock is on, and that's only when switch 1 is being pressed. Otherwise, both of them are just going to be on all the time, and switch 2 doesn't really have any effect on these ones. So I'm going to turn it on now, and we'll see that it behaves as expected. So we see when switch 1 is not being pressed, the clock, the NAND gate here, and then the 2 NAND gates with the OR here result in both of these just being on. But when I turn switch 1 on, they flash opposite the clock. And we can see switch 2 doesn't really have an effect on it.